right, Math 9, I want to look at section 9.3. Thankfully, this is the last one where we're going to talk about graphing. We're going to go into probability after this, which I like a whole lot better. Just personal preference on my part, but anyway. Section 9.3 talks about something called lines of best fit. Lines of best fit are really just a line that you put on the graph to help you more clearly see what the trend in the graph is. So I'm on page 324, and I've actually put up the graph that's at the very top of the page, and it talks about the relationship between the area of a sea and the greatest depth of the sea. The line shown on the graph, now I don't have my line here, they draw a line. So here are all the dots, and what we can see is that there is a general shape to the graph. There is a general idea that as we go across, the dots are going up. But to give it just a little bit more clarity, people put on graphs what we call lines of best fit. Now, a line of best fit is a straight line going in the direction of the dots. If the dots are going up, then your line of best fit should be going up. If the trend of the dots is that they're headed downward, then your line of best fit should be going downward. I actually see a lot where the lines are headed down, but you draw your line of best fit up. That's not how that works. It goes in the same general direction that the dots go. Always a straight line. Don't sit and try and play connect to the dots with a scatter plot. That's not going to work. It's a straight line. Now, you want to make the straight line in such a way so that you go through the maximum amount of dots and you have approximately the same amount of dots above the line as you do below the line. So when they draw it, they basically start here and they kind of go through almost like that. Okay, so that they've gone through 1, 2, 3 dots, and they've got 1, 2, 3, 4 above and 1, 2, 3, 4 below. And that's how they kind of draw their line of best fit. Now, I might see somebody try and do it like this. But if you go that way, you really have only gone through a couple of dots. And you want the line to be as close to as many dots as you can make it. If you made it where this dotted line is, this dot's really, really far away from your line of best fit. And this dot would be really, really far away. Now, I know in my line of best fit, this one's quite a ways away, but it's not as far as, say, as say this dot is to this, or this dot is to this line, okay? So there is a best way to do it. So while this one the dotted line I put on there might seem reasonable as a line of best fit, it's not your best option, okay? So again, criteria for a line of best fit: you want it to go through as many dots as possible, have approximately, it might not work out exactly, but approximately the same amount of dots above and below. And you want the line to be as close to as many dots as you can make it. You don't want it to go through a bunch of dots, but be really, really far away from a bunch of other ones. So they're saying in the textbook, this is your best option for a line of best fit. Now, the reason why we do this is to make answering questions a little bit easier, because now when we answer questions, use the line of best fit to, and the word they use is interpolate. I'm going to tell you what that means in a minute. To interpolate the greatest depth of the sea with an area of 1.4 million kilometers. Okay, these areas are in millions. So 1.4 would be right about there, okay? Now, if I interpolate, what that means is if I'm going to look for the depth of the sea at 1.4, I'm not going to go up and actually look for a dot. What I'm going to do is I'm going to go up to where my line of best fit is. So I'm not looking for a specific dot. When I interpolate, what I'm doing is I'm going up and I'm saying, there's my line of best fit. And if I come across, oh, that looks like about 3,700 meters. So my best guess, my best estimate is that if an area is 1.4 million square kilometers, the depth, the maximum depth is going to be about 3,700. That is interpolating, okay? Then they talk about this word extrapolating. You might have heard that word even in a class like English, extrapolate this or extrapolate that. In the word extrapolate, so I'm going to do a little bit of an English class here. Interpolate and extrapolate. Interpolate has the word inter, meaning like inside. So the data that they wanted was within the graph. It was in the dot somewhere. Extrapolate has the word extra in it. In English, if they ask you to extrapolate something, so if they want you to extrapolate what the author was thinking when he wrote this scene, what you're doing is he didn't actually tell you what he thought, but based on what he said, you're going to kind of infer and figure out what you think he was thinking during that. So it's not something that is right there in print, but it's something that you can figure out based on what's there. So in graphing, when we talk about extrapolate, it's the same idea. So here's what they ask. They want you to use the line of best fit to extrapolate the area of a sea if the greatest depth is 9,000 meters. And you can see that in terms of depth, 9,000 meters isn't on my graph, right? It's outside of it. Extra, it's outside of it, all right? So what I would do, I don't have space, but what I would do is I would actually continue my line a little bit, and I would say like 9,000 would be up here. And so I would come across to where my line would be, which would be, I don't know, right about here. And then I would come down. And I'm going to say that's going to be at about 3.1, 3.2 million square kilometers, okay? It's outside of the area where the dots is. It's outside of even where my graph is. But what I could do is I can extend my graph, I can extend my line a little bit and make a best guess based on the trend that I'm seeing. That is extrapolate. All right. So in the example on page 334, and I'm not going to spend a lot of time, okay? I'm not going to spend a lot of time. There's just a couple of things I want to pull out of there. They talk about the table shows the winning times in the women's 400 meter track and field event at the Olympics, and they give the year and they give the time. So they go across the bottom for year, and the years go every 4 years from 1964 to 1992. So I'm going to do squares every 4. I'm going to go 1964, 1968, 72, 76, 80, 84, 88, 92, and that's where they stop. Okay, so I'm going to do that. Now, here's some of the things I want to point out. 0 is here. Then we jump to 1,964, and then we count every 4 years. Well, there's a lot of years in between year 0 and year 1,964. So when you don't follow the pattern in that first square, you can draw a little squiggly line which says, listen, I skipped a bunch of years there, and I'm starting at 1964. This would be 0. There's a bunch of missing years. We're starting at 64 and going every 4 years. Same thing along the top. Times actually range from 48 to 53. So they count by ones. But I'm not going to count by ones and go 0, 1, 2, 3, 4, all the way to 53. The data starts at 48. So what I'm going to do is I'm going to go listen. There's a bunch of missing numbers in here. And then at my first square after 0, I'm going to start at 48, 49, 50, 51, 52, and 53. Okay? And then they have a bunch of dots. And I'm not even really going to pay attention to the table. I'm just going to put some dots here. 64 looks like it's close to 52. And then 72 looks like it's close to 51. And then there's like a dot down here, and then like 1, 2, 3, 4. I'm not really paying attention to where the dots are. But that's the general shape of the graph. Just a second. Hey! So in this case, the line should actually go down because the dots are going down and then sort of leveling off down here. So when they draw their line of best fit, what they do is they kind of go, let me fix a little bit. They kind of go like this. So I've got 1, 2, 3 above, 1, 2, 3 below, and I've got it going through 1, and it's relatively close to my dots. Okay, and then that's all they wanted you to do was draw the line of best fit. So this homework is going to be drawing scatter plots and putting lines of best fit in and answering questions. I was looking at your graphs already. If you're making them kind of small, I indicated that to you. I did kind of make some notes if there were some things that I thought you should be paying attention to. So just keep in mind that if I had smooshed this all together, it makes it harder to put in an accurate line of best fit. All right? So I will give you a few to try, and then in the next time we talk, we're actually going to do some probability. We really only have a couple of sections left, and that's it. I really apologize for the dogs. I will talk to you again soon.